Alright, here we go. We're at work. This thing's gonna be loud, so I'm just gonna shut it off. Somebody remind me to turn it back on before I leave because it takes 24 hours to get back to temperature. But yeah, so we're at work on a Saturday. I'm obviously wearing a company logo. Legendary. We're gonna be working on this Fluke 87.5. So this is like super simple stuff, my job. We'll go through it a little bit. I'll show you kind of what I do, and yeah. I know this isn't the best angle to be able to read this screen and this screen, but you're just gonna have to trust me, because I'm not gonna reshoot every shot to get a second angle of it, so Sigma. So the first thing you're going to be testing is AC voltage. The big difference between AC and DC is AC carries a frequency which allows it to go both directions in a circuit, which is why telephone lines use AC, because if the line goes down, you can still get power on both ends of the line. And your electronics use DC because it's very specific at which direction the electricity is flowing, and that's why all your devices have these dumb little things on them that you plug into the wall. It's an AC to DC converter, so that the power that it's giving your device is DC. So to test this multimeter, we are using this machine, which is also made by Fluke. It's the Fluke 5520 Alpha. It is a calibrator. It shoots out very specific voltage, frequency, current, capacitance, resistance values, temperature values via thermocouple, and I'm sure it does other stuff too. On this computer screen that you can't see, because I have a confidential Excel sheet up, so it's got all of the values that I need to test on this multimeter, and it also has the ranges that it has to be within in order to be properly calibrated. So I'm going to type in the numbers on here, read what it says on here, and then enter it into my Excel sheet so that I can give the customer all of the data that we took while calibrating the multimeter. So now the number that's on this screen, which, fuck it, is 330 millivolts at 60 hertz, comes into here, and you can kind of read it. 330.1. So I'll record that on my Excel sheet, and it's good. Now, if it were bad, inside this multimeter, there are little potentiometers, which I'm not even going to explain, but you spin those to adjust it and put it back into tolerance, and that way we can return back to the customer. This one's passing so far. I've only done one test, but we'll see how it goes. Yay! So, AC voltage passed with flying colors. It's a multimeter, but they're not usually bad. It's like as easy as calibrating gets. This is like a torque wrench. Next test is frequency, so we're going to do the same type of thing. It'll give us a specific voltage to run the frequency as. So this first test point is running 150 millivolts with 99.95 kilohertz. Operate, same fucking thing. Come on here and turn it to frequency. 99.95. Look at that. So I just made myself a coffee because I'm tired. I like my girls like I like my coffee. White, low fat, and sweet. Jokes while I'm here by myself. Oh fuck. Alright, so now we're moving on to DC voltage, which, like I said before, same thing as AC, only it doesn't carry a frequency with it, so it's singular direction. That's why electronics use it. I don't know what else to tell you with that one. That's basically it. So this one's really easy to test because I don't even have to enter a frequency. So 3.3 volts. Operate. And bam, look at that, 3.3 volts. It's amazing. This is my job. This is why you don't go to school, kids. Drop out. Fuck college. Pass DC current is fine. DC current is really easy because there's no fluctuations like there is with AC current because of the frequency. Our next test is resistance, which is measured in ohms. That's why Ohm's law and other stuff like that is important if you learned it in school to remember if you're going to do stuff like this. But because I have this calibrator, it makes my life really simple. My first test point is 330 ohms and 300. Oh, fuck me. 330 ohms entered on this, and if you look at the screen, it says 330, sometimes 0.1. We'll call it 0.1. It's better to decide in the side of error. And now we'll do the rest of resistance. Now we're getting into the stuff where if you're not careful and you don't know what you're doing, you'll kill yourself. We are about to test DC and AC current, which is amperage. Cool thing about amperage is it'll kill you. So if you don't know what you're doing, word of advice, just don't do it. We're going to start with a very small amount of amperage, 330 microamps DC. Outputs there. This is where you don't want to touch the leads anymore, because even this small amount of amperage you will feel, and it's not pleasant. And 330 microamps, 330.1. Regardless, it's intolerance. I'm going to do the rest of these and not record while I'm doing it. And that basically finishes this with a couple extra little tests that are irrelevant. So yeah, see you later. Alright, we are back. Ready to do the next thing. Next thing we're going to be calibrating is this DC power supply. Triple output, made by Keysight. It's pretty good shit. I'm going to be using this Agilent 3458 Alpha digital multimeter. This current shunt, which basically you put your positive lead in here and your positive lead comes out here, your negative lead goes in, negative lead comes out, and this bar connects the two. It converts current into millivolts, so you can get a more accurate reading on it in the multimeter. So I just looked through my data sheet and the stuff I'm going to record, and a lot of it I can't show you because it's all proprietary, so I'm just going to show you some random stuff with this power supply. At a test port 1, I'll show you voltage and current, and that'll basically be it with this, because I can't show you the actual calibration process. So, wrong machine, that's how you blow this up. Alright, so we're connected into our multimeter. This is basically the same thing as the little handheld I was doing before, only way more accurate. So we'll turn our output on, 0 volts, 0 amps. We're in our first test port. It only goes up to 6 volts, but it's got a higher amperage that I can show you afterwards. So we'll run it up, and it's outputting 1 volt exactly, 1.000. And if we come down here onto the multimeter, I don't know, clearly you guys are going to be seeing this, but it says 0.0000, so it's more accurate than even its own display suggests, which is a good sign. So we'll run this up. We'll do our next test point at 6 volts. This also goes negative. I'm not going to go through all that. 6.001 it's outputting, 6.001. So it's spot on with that. Turn off the output for a second. We'll come over here and get our current shunt, which is a cool little dangerous machine. Note to any users that are using this, I'm about to run current through this open bar. Now, when it's running, don't touch it, because it will kill you. And that's not even like a joke. Voltage you can get yourself with pretty high. I've got myself with 1,000 volts once or twice. It stings a little, it hurts. 0.1 amps will kill you. So we're going into the current shunt. I'll put this up here if it will stay without falling. There we go. So we're going from the power supply into the current shunt, and from the current shunt we are going back into the voltage probes, because it's going to convert current into millivolts for us to be able to read on the multimeter. So we'll turn this back on. and it instantly recognizes the current shunt is there. It's outputting 5 amps. Now remember, I just told you 0.1 amps will kill you. It's outputting 5 amps. So you come down here, it's outputting 5 amps and some negligible voltage, 4.993, which is intolerance. So it's good to go. That's all I can really show you with this. Just a little insight as to what I do for work on a day-to-day basis. Thanks for tuning in. Thanks for being here. I hope you liked it. It's just a little bit more as to what I do for work. Hopefully one day I can show you my specialty, which is radio frequencies, but that'll come on a different day. Maybe down the road a little bit. Anyways, like, comment, subscribe, follow me on Patreon, Instagram, Twitter, the whole thing. And until next time, I'll see you guys later.